Right, so we're now recording. What I'm going to be covering today is optimization of corridor mass hall planning within Business Center, and then looking at sending that information across to Tilos for the time and location scheduling portion. So what I'm going to start with in Business Center is an extremely simple project, just to give people the idea of what Business Center can do in a really simple format, and from there we're going to then take it up quite a few levels and look at some other project data that we're going to work with. So in this first example, let me just change how I've got my screen set up. Basically here we have a very simple project that is essentially a sine curve. So the green line here is our existing ground in the profile view, and the flat line is our design. Looking at that in 3D, we can see that same information there. So we have cut material on one side of the corridor, and on the right hand side we have fill material. Now, extremely simple scenario, I know, and not that you're going to come across this on a major highway job. In terms of mass haul, all we need to do is shift cut material from this area here, move it to the right, and dump it in the fill location, assuming of course that you're allowed to shift this material in that manner. So what I'm going to look at doing here is bringing up our mass haul diagram. So this has already been configured, and on our diagram here we have a range of lines. So to explain the mass haul diagram, it's rather simple. The red line, which I'm about to click on, which is now highlighting pink, this defines our cut over distance. So in the vertical column here we have total volume. In the horizontal column we have distance down the road. So in this case, the cut only occurs on the left-hand side of our alignment. So for example here, our cut, or total cut over distance, goes up until this point. It's cumulative, and then we do not get any more cut material, so it remains flat as we are in a fill location here. The blue line represents our fill material. So on the first half of the job, there's no fill because we're entirely in cut. As we reach the second half, this line goes up to show that we have fill material required, and that ends at the end of the job where we then have no more material needed. We have some lines here which define the different materials in the ground that we may be cutting and filling with. We can ignore them for now. In a simple point of view, cut minus fill gives us balance, which is the green line. So basically, as we've got a lot of excavated material at the start of the job, until we get to halfway, that reaches its peak. So we have an excess of material. As soon as we then have a need for fill on the right hand side of the job, this line goes down as red minus blue equals green. That's a very simple explanation of the mass haul diagram. What I'm going to do now is jump across into an example project and look at how we set up a project and what we can then do with it. So in this project here we have already a corridor. So if I bring this up on screen in a cross-section view, we have in here we've defined our corridor. So we have a defined fill material, which is showing here in black, and as I scroll along the alignment, you can see as we go through cut and fill, we're coming across different materials. And as I get into a large section of cut, you can see here we have 3 different cut materials. So what's happened is, defined in the background we have a material library. So in here I can define various materials on the job. I've been very generic in this example we have soil, which could be topsoil and clays, and in this instance I've said the usability as structural fill of these materials is 0. So basically that slice of brown that we see down here in the cross-section view, all that material has to be thrown away because we can't use it on our job site. We then have sand below that. Right, so on the sand material we can see here that's shown in yellow. Just trust me when I say that the soil properties are 100% usable as fill. And then we have existing rock in the ground as dark grey. Before I use that as fill material on the job, we need to turn it into crushed rock, so we have a material process that changes in the background our normal existing rock into crushed rock. So what I could define here is if we had a volume of 1 cubic meter in the ground of rock going into the crusher, that may turn into 1.1 cubic meters out the other side, or you could have 0.9 with so much waste of various other granular material. In this example I'm keeping it very simple, but this crushed rock is what we're going to be using as fill, and this is defined, in this case I've defined a material set. So this is quite new to Business Centre, where I can say that depending on what material is available, I want to use either sand or crushed rock, so it's going to use the cheapest option along the job. You can define as many fill materials as you want for a corridor, so you could have your main structural fill in the center of your alignment and then lower grade materials out to the side or different along certain sections of the job. Here we've just got a generic use sand or use crushed rock to fill. So with all those parameters set, we can then see in our cross-section view where we come across those materials. In the plan view you can see we have, along our design here, we have red and blue indicating our cut, our fill zones. That doesn't specifically say what materials under there, but if you zoom in you can maybe guess that this cut area can be used in this fill area. But next we're going to get into the actual mass haul itself. So first up I'm just going to disable some options I have in the background, which annoyingly are hidden behind my control panel. So if I turn off some various options along the job, and we'll come back to these later. What I can then look at doing is running our first mass haul. So to create an analysis, I push the button here, and we can call this shifting dirt or something else. This is going to be applied to our only corridor on the job, which is the main road. And normally you're going to set a sample interval of 10 or 20 meters. What the software is going to do is cut a cross-section every interval, look at the cross-sectional area of the materials, average that, multiplied by the distance to get the volume. The smaller your cross-section interval, the more accurate your volumes will be, and also the longer it will take to calculate. So to speed up this process today, I'm going to set this at 100 meters just so we don't have to wait for the processing time, and then we can define a haul cost along the job. So traveling down the alignment, let's say it's going to cost me 50p per cubic meter a kilometer to shift materials. And then we have two options. We're going to utilize dump sites and quarries shortly. If I say a quarry only has 100,000 cubic meters, I don't want the software to try and take 250,000 from it because it's cheap. So we want to leave this set to yes to respect those capacities. And because I have different materials defined, I want to not use generic fill. So we have the option here to utilize the actual materials in the ground. Hit OK, and what this is going to do is do some calculations in the background and create our first mass haul. So now you can see what that's done. It's created a truck over here on the left hand side underneath our corridor, and if I right click on that I can bring up a corridor mass haul diagram, which is also in the menu up above as well. So this is quite similar to what we had previously, but with a little bit more complexity. Like before, we have our red cut line, we have our blue fill, and we have the balance material in green. If I zoom out, we can see our total excavation is a lot greater than our total fill. So that's going to create a excess of material, which is then highlighted in this flag. So if I bring up the properties of that, it tells us at the end of the job we have a deficit of good material, and we also have to get rid of a lot of waste material, which is the soil that was defined in our material library in the background, so that brown material from the cross section. So what we need to do is utilize the haul roads and the dump sites to get rid of the bad material, and the quarries to bring in good material. So looking at running this in a step-by-step process, we can add in more parameters. So the first one on this job site is we have a river, which is going to block material movement along the job. So if I create here a barrier on the job, and place it at this location, I can then say I can move material around that barrier if I utilize the haul roads. So I hit apply, that puts the blue dot here, and we then have the river listed on our mass haul. And I now need to try and get rid of this screen, and if I push the refresh button, this will then update my mass haul diagram. Our total cut and fill remain exactly the same. We can see we now have a blocker at the river, which creates another flag. What this has done is our balance line has been split into two. So basically we have two separate mass hauls on each side of the river, because there's no way to transport material from left to right. So to get around the barrier, we can then utilize our haul roads. So I have a range of haul roads on my job. They can have a price, which is a lot cheaper than shifting material down the main alignment in this case. So if there was the option to shift material on a haul road the same distance as taking it down the main alignment, the software would utilize that option. So it's looking at the cheapest way to move material. If I activate this, and refresh our mass haul diagram, that's going to then utilize the haul roads. So if I zoom out, the haul road being used is being shown in red here, which if I click on the, sorry, and I forgot one other thing that I was meant to disable. We'll just pretend I didn't do that and come back to it in a second. So if we had good material to move around the job, the haul roads would be used to ship material from location A to location B. In this case, the software isn't picking up any useful material to move. So if I turn on my quarries, dump sites, and also the rock processing sites, and refresh the mass haul calculations, What's going to happen is we can see material being shifted. If I click on the diagram, we see there's material being shifted off our main road here, down this haul road and into our dump site. If I bring up the properties of that, we then find out how much material is being used. So being moved. So we're getting rid of 205,000 cubic meters. We also find out that there's still a lot of spare capacity at that dump site, which is good. And we have our various haulage and site costs to get rid of that material. So if you wanted to do this cheaper, what you could look at doing is adding in, say, more dump locations closer to the job site that may be cheaper. They could be very small dump sites, but along the course of the job, that's all going to add up to a lot of savings. So essentially in Business Center, if you want to run different scenarios, the easiest thing to do is to copy the project that you have here and then edit some parameters and run scenario A against scenario B and see what's going to work out cheapest for you. The good news here is the red flags have disappeared from our mass haul diagram, which means our project now balances. So we're bringing in material from the various quarries, and we're also sending a lot of existing rock off to crushers to be, and in some cases traveling long distances to then be properly used on the job up at this end. Because it's cheaper to shift material, as we discussed before, along a haul road than it may be along the course of the alignment, as there's a factor 5 difference here in those haulage costs. Once we're happy that we have our mass haul optimized within Business Center for the volumes, the next thing we need to do is we've created some haul ranges here. So to create a haul range, all I do is push this button and we'd call it a truck or something else. Put in a maximum distance that I want this truck to move material, and then say, can the truck drive anywhere along the job, or will it only move material down the main alignment? So in the case of the bulldozer, you don't want that driving down the local high street. You would only have this driving on the alignment. Maybe for an ADT, you could have that driving alignment to an off-site dump site, rather than if that was a separate road to going down, again, the main high streets. In this case, I have 3 machine types already defined. We have the bulldozer to shift sand 50 meters. And what I forgot to show you earlier is how this looks. So we have a bulldozer here and a ADT. If I auto balance the mass haul, in our mass haul diagram, clicking here, we see we're using a bulldozer to shift the short haul, so 50 meters of cut into our fill location. If I bring up the properties of that, it will then give us what's the volume of material moving, where are you cutting, and where are you filling. If I then click on the ADT, that is then shifting over the top of the bulldozer from this larger location to this location. So quite simple, but if I go into this project, we have our 3 haulages. I then auto balance for all those materials. It's going to take a little bit longer to calculate, but what we then end up with is, like before, different machines being used. So in this location there is rock coming from the crusher, which is up here, driving along this haul road, and there's rock coming from that crusher as well, and that's being used to spread material along that part of the job. Looking in at some of these yellow movements, you can see material then being used in fill at the start of the job. And again, where is that coming from? We have a very large section of cut in that location. So we can see where we're cutting and then the various fill range and what machine are we using to shift material. 2,500 meters, so this is our articulated dump truck. and the average haul distance is 1.4 kilometers roughly. We also see here that we're shifting roughly 25,000 cubic meters of material. So Business Center gives you the cheapest way to shift material from point A to B based on volume and material type. What it doesn't give you is how long is that going to take based on the number of machines you're going to use to move this material, which is why Trimble purchased Tilos, so that we can look at the actual scheduling of this information. All the volumes that we have in Business Center and represent in this diagram here, you could say are really great to look at, but if you needed to export that off to Excel, there's also a range of reports within Business Center. So you could run a corridor earthworks report in multiple formats. Let's just change this interval so it runs faster. And this first example is going to be the basic report. So on our first page we're going to get a simple overview of the volumes, and this is basically just a summary of the mass haul diagram. So if I scroll down a little bit, we have the cut quantities of soil, sand and rock. So important to know, especially if you need to drill and blast rock, it's going to cost more to excavate that material than it is the soil and the sand. Scroll down a bit more, we have our subgrade quantities, so asphalt and base material that we're laying. These I haven't included as part of the mass haul, as it's basically you're laying a rectangle. It's not exactly the hardest thing to calculate manually. And we have our general overview. What we get here is every 100 meters we're cutting a cross section that then gives you the cross-sectional area of cut or fill. So red for cut, blue for fill. In this case we'll average those two, multiply by the 100 meters and give you your fill material. And at the start of the job we need material, and as we go further down the job we will then see in this location, so roughly change 2,500, we change from a deficit of material to a excess, and this is at this location here. So on our balance line, that's what's being summarized in the report. If you ran that report in a more advanced setting, I'll do that again and change our report options to launch in Excel. It's just doing the calculation again in the background. This clipping boundary that was shown on screen just before, so if I have something selected there, what that would look at doing is I only want to report on certain areas of volume. In this case I had something that wasn't a boundary. The advanced report gives you a lot more detail. So similar to the last report I just brought up, but this time it breaks it into specific material types. So we have the various soil, sand and rock that we're excavating. You can see we don't have rock being excavated at the start of the job, it's not till we get further down. And then how that's all being used on the job for our various fill materials. I won't go into that in any more detail, but it's suffice to say you get all the information you need on the job. These balance lines that are shown in a mass haul diagram, again they can also be reported out into Excel, so that rather than clicking on the lines to get the volumes and the cut and fill locations, that's listed for you in an Excel environment. Right, But let's shoot across to Tilos. So now that we've got our mass haul complete in Business Center, I just select it here, push the export button, and under the construction tab just near the bottom we have the Tilos exporter. So I'm just going to send this off to my desktop. And we can set the width here. This is just a parameter to show the size of the quarries or dump sites within the Tilos application. Hit export. And that's now been sent to my desktop. If I jump across to Tilos, I'm going to go into a blank template and create a new project. And I have some templates that I can use. And what I need to know here is what is the start and end location of my job. So if I go back to Business Center, we start at change 0, and here we go to, let's just say 11,400. Then we have our start and end date for the job. We're going to work 8 hours a day, 5 days a week, and hit apply. Because I managed to have my license expire in the last couple days, it's also telling me I can't save this without more than 10 graphic objects, but because we're doing a demo, I can luckily still import the information I need and show you some more stuff. So first we just get a blank project which we're going to import information into. So to do the import, get a file, import. We're bringing in the XML file from Business Center. This is the one I've just exported today, so you can see I'm not actually cheating for this. Push open, next, and finish. And not perfectly set up because I haven't tweaked the template yet. In our top view, basically we can look at adjusting the view. So what I have here is our cut and fill profile for the distance along the job. So if I change that a little bit more to be maybe 150 to 300. Sorry, wrong button. And tick the box to use a fixed scale. We can see where we have our cuts and fills occurring along the alignment. I just also changed the size of my screen here. Below that we have an option to define soil cut and rock cut as that appears along their job. So if I went in here, I could actually go and define the histogram to define certain information in that column. In this case, rather than showing how Tilos works, I'm going to take the lazy options and turn off 2 of the charts and make this one a lot smaller. And the orange information is our balance line from Business Center. So this is the green line that you'd seen earlier. I've just hit F5, and what that has done is gone and refreshed how we see the mass haul diagram. So I'll extend the size of that. The mass haul diagram here is going back to Business Center. That's all these lines in our view here, showing us where we're shifting material to and from around the job. So we can see here in brown we have the soil that we're excavating, and below that we have the rock that we're drilling and blasting, and some material you can see being taken off-site to the crusher. And as I go further down the job, we also may have quarries and dump sites being used. So above our flat line here, we've got the various cuts, and below that we have the fill activities. We have lines here showing, I'll just zoom in on this, click on one of these lines, and it tells us that we're shifting material to the dump location here. We're using a truck and an excavator. That's the volume of material that we're moving, and we also have a haul distance there of approximately 6 kilometers. Zoom in on that, and if I drag that line up, we can see here the volume and the distance. So all those tasks of the shifting of the materials is what we're going to look at scheduling in our schedule view. So to explain Tilos, vertically we have time, horizontally we've got location, and in the blank space is where I'm going to create the schedule. Over on the left hand side we have our various material types. The ones that have come across from Business Center are the 01 to 04 numbers. They're the ones that are in my material library. So go into here, we can see 01 to 04. Just numbered them like that so they're easier to find in what is otherwise an existing template. And go down a bit further, and I have my various machine haulage types. Again, back in Business Center, dozer, AD10 loader, truck and excavator. So we have in here our bulldozer, our AD10 loader, and the truck and excavator. What I'm going to demonstrate first is going to fail, but so you know where this information is located, we'll show you this process. If I right click on one of the hauls here, I can say create a cut and fill task, and it gives me an error message. What this is saying is that if I click on this bulldozer here, I haven't set up the cut and the fill tasks inside the template. If I look at one of the one that's already existing in the template, we have a cut and load to a truck and a fill dozer with a crew. So these are the settings I need to define for first the bulldozer. So cut here, we're just going to use cut and push with the dozer, and then somewhere in here we should have fill push dozer crew. Do the same thing for the ADT, except this time we're going to use cutting and load to a truck, and we're going to have fill a dozer crew pushing out the fill material at the far end, and the same thing for the truck and excavator. Almost did that in the wrong order. So that's our template configured. If I then was to right click on one of these activities now, I can create a time to start that, and that would then fill out the schedule. The other option we can look at doing is, rather than clicking on all these tasks individually, I realize you're not going to do this as a proper scheduler. However, to show some of the power of Tilos, what I can do here is click inside that diagram, go down here to my menu bar, and I can create a filter. So at the start of the job you may just want to look at stripping topsoil, so I'm going to filter to just the different material types. So here we've got soil that's being cut and then being dumped off site somewhere. So you could filter to different materials and work your way down the list, have our rock cut and being blasted going off to the quarry and schedule those activities, or we could maybe just filter to certain machine types such as the ADT and the loader and see soil being used, the sand being shifted around the job site. In this case, if I select all of those tasks, then create events from them, hit OK, and we now see we've got a range of cut and fill activities along the job. Now if I click on one of these boxes, that then gives me a calculation rate, so how long is it going to take to shift that material. And if I look at the planned allocations here, we've got the dozer moving material. If I look at the cut event, we have an excavator being used to move that material. And what I could do down here is look at adjusting the number of machines. So if you were to add extra trucks into this equation, let's just hit 5 there, hit OK. You can see that shortened the activity. Push F9, that's then shortened the fill as well and sped up the time that's going to take to construct the project. So fairly basic to go through and create a schedule based on just filtering materials. And what that then does is this fills out our resource allocation on the right hand side of Tilos. So here we can see volume of material that's being moved over time. We also see the number of operators and machines needed at any given time. So here's where I've expanded the number of trucks and excavators needed, and then we get our return on investment coming back to us as well as we're getting paid to cut and fill along the job site. So that's the main link between Business Centre and Tilos. Jumping across to a real project. This is from New Zealand, in my home country. You can see in here there's a lot more complexity in terms of what's being shown on screen in the number of items along the job. So there's a lot of different parameters of quarries, dump sites and processing sites. In the background there's also a lot more materials, so different materials that we're cutting through that all have different parameters for use as structural fill, and that then will create a far more complex mass haul diagram, which you see below, where there's a lot more material movements going on. How that then looks in Tilos is at a zoomed out view. We have here our profile diagram up the top. What I've also done is use a new function in Business Centre where, going back to Business Centre, you can see the alignment here is running kind of north to southeast. There's a function in Business Centre where you can flatten out the curves on the alignment, so you can then take a screen snap rather than stitching together pages of PDF. It flattens out the alignment so you can see where various information sits along the job, which can be very useful for seeing where your bridges and other activities are. Below that, what I didn't have defined in the last project we just went through is the quantities of existing materials you're hitting, and then also what you're using as fill material. Zooming out a lot, we can then see a much more complex mass haul diagram for shifting all those various materials from their cuts and fill locations, as well as the crushers, quarries and dump sites. And with that, that concludes the presentation today.